All right, let's talk about that moment. You know the one. You're in an interview and the question drops. So, tell me about object-oriented programming. Your heart kind of sinks, right? Well, if you've ever felt that, you're exactly where you need to be. We're going to break down the toughest OOP questions today and give you a solid game plan so you can walk in and answer with total confidence. Look, let's be real. Nailing these questions, it's often the one thing standing between you and that developer job. The stakes are super high, and you can feel the pressure. Because think about it. No team lead wants someone on their team who's shaky on the basics, Stuff like abstraction, encapsulation. It's the absolute foundation of so much of what we do. So, what's the secret weapon here? Is there a trick? Well, kinda. It all boils down to this super simple but powerful idea. The 3 Ps. You've got to be prepared, be to the point, and be practical. Seriously, that's it. This is the framework we're going to use for every answer, and you'll see just how powerful it is as we go. All right, Section 1, cracking the OOP interview. And here's the deal. It's about 70% what you know and 30% how you say it. So first things first, you got to get your head in the right space. A tech interview isn't just a test where you spit out facts. It's kind of like a performance. The way you structure your answer, the way you communicate, that can be just as important as the technical details themselves. I love this quote because it's so true. You could be an absolute rock star developer at your current job, a total coding superhero who ships huge features. But an interview? That's a whole different ballgame. Being prepared is what makes all the difference. Knowing your stuff cold and having your examples ready to go, that will always, always beat raw talent that just can't explain itself when the pressure's on. Okay, Section 2 is all about OOP's core idea. We're going to answer the why and the what. Let's get right into it. The first question you're probably going to get isn't some weird, obscure detail. Nope. It's about the big picture. Why do we even have OOP in the first place? So there it is. Why do we need OOP? The interviewer is testing you here. They want to see if you get the fundamental why. Just saying something vague like, oh, it helps organize code, or it makes code better, that's a huge red flag. You gotta be sharp and to the point. And boom, here's your answer. It's that simple. Object-oriented programming helps us to think in terms of real-world objects. That's it. It's all about modeling our code after reality. So let's say you're building software for a hospital. You're not thinking about random functions, you're thinking about things. You've got a patient object and a doctor object. The patient has properties like a name and an address. The doctor has a method like treat patient. See? Your code starts to look and feel like the real world, which makes everything way more organized and easier to manage. That's the whole point.
And the 2 absolute basic building blocks for all of this are the class and the object. A class is simply the blueprint. That's the best way to think about it. It's the plan. So a class called employee says, okay, every employee will have a name and an address. Then an object is the actual thing you create from that blueprint. So E1 is an object, a real specific employee. You can make tons of objects from one single class, just like you can build a whole neighborhood of houses from one set of blueprints.
All right, Section 3, now we're getting into the big 4, the 4 pillars of OOP. And listen, when you're in an interview and the pressure is on, it is so easy to forget one of them. But don't worry, we've got a great little acronym that's going to make sure that never, ever happens. All you have to do is remember API. That's it. Abstraction, polymorphism, inheritance, encapsulation. APIE. Say it with me, API. This isn't cheating, It's just being smart. It's being prepared. It's a simple trick to make sure you have the answer ready when you need it most. So let's do a quick flyby of what these mean. Think of it this way. Abstraction, that's your TV remote. It just gives you the buttons you need, hiding all the crazy electronics inside. Polymorphism, that's you. You act one way at work and a different way with your friends. Same person, different behavior. Inheritance is easy. It's like you getting your eye color from your parents. And encapsulation is like a pill capsule. It holds all the medicine together and protects it. That's the 10,000-foot view. We'll dig in more, but that's the gist. Okay, pay attention here, because this is where a lot of people get tripped up. The difference between abstraction and encapsulation. The easiest way to remember it is this. Abstraction is the what, and encapsulation is the how. Abstraction is the big idea, the design choice. You decide what features are essential to show. Encapsulation is the actual coding part. It's how you hide the rest using things like public and private. So, bottom line, you use encapsulation to achieve abstraction. One is the goal, the other is the tool. Okay, section 4. We're going to do a deep dive into what might be the most powerful pillar of them all, polymorphism. The name sounds complicated, but the idea is pretty cool. It just means many forms, and it's all about one object having the ability to act differently depending on the situation. And polymorphism comes in two main flavors, overriding and overloading. Method overriding happens between a parent and a child class. Imagine a parent class has a draw method. The child class can override it with its own brand new way of drawing. Same name, new behavior. Now, method overloading happens inside the same class. It's like having a single add method, but one version takes 2 numbers and another version takes 3 numbers. Same name, just a different signature. It lets you have flexible versions of the same action. And this connects directly to the two types of polymorphism. Static polymorphism is decided at compile time. This is achieved with method overloading. The computer knows exactly which version of the method to use before you even run the program. It's all locked in. But dynamic polymorphism, that's decided at runtime. This is achieved with method overriding. The program has to wait until it's actually running to figure out, hey, should I use the parent's method or the child's special version? It's a decision made on the fly. All right, deep breath. We've arrived at section 5. This is it, the final boss, the one question that can make or break an OOP interview. Abstract classes versus interfaces. This topic creates so much confusion, but nailing it shows you really know your stuff. Yep, you guessed it. What's the difference between an abstract class and an interface? And look, anyone can memorize a definition. That's the easy part. But explaining the difference clearly, and, crucially, explaining when you'd use one over the other, that's what separates a junior-level answer from a senior-level one. So, let's start with an abstract class. The best way to picture this is as a half-finished class. It's like a blueprint that's partially complete. It can have some methods that are totally coded and ready to go, providing some default functionality, but it can also have abstract methods, which are just signatures with no code. And here's the key. If a class inherits from this abstract class, it is forced to provide the code for those missing methods. It's a way of saying, here's a starting point, now you have to finish the job. Now, an interface is totally different. Think of it as a strict contract. It is 100% abstract. It has zero implementation code, none. It's just a list of method signatures. It's a promise. When a class implements an interface, it is signing a contract that says, I solemnly swear I will provide my own code for every single one of these methods. And the absolute killer feature here, a class can implement multiple interfaces. It can sign multiple contracts, which is a huge deal. So let's put them side by side. The key differences are right here. First, implementation. An abstract class can give you some code to start with. An interface gives you nothing. It's a pure contract. Second, inheritance, and this is the big one. A class can only inherit from one abstract class, but it can implement many interfaces. And that leads to their purpose. You use an abstract class when you have closely related objects that share common code. You use an interface when you want to define a capability that completely different classes might share. And this is what it all comes down to. Acing your OOP interview is not about memorizing definitions from a textbook. It's about proving you get the why behind the what. It's about being able to answer, okay, in this specific scenario, would you use an abstract class or an interface, and why? When you can answer that question with confidence, you're not just a candidate anymore. You're a problem solver. You're showing you're ready to build great software. So the real question to ask yourself is this: do you just know the facts, or do you understand the strategy?